Good evening, dear students. Today we will be discussing the equations of bisectors of two intersecting lines. This is in continuation of our series of classes on points on straight lines. So let us start. So what is the bisectors of two intersecting lines? Let us understand this first. you know Let us consider two straight lines. So one straight line I'm drawing in green color. So this is one straight line, and let us give this name of that straight line as L. And another straight line, let us give in the blue color. This is something like this. This is another straight line, that is we define as L dash. Okay, now these two straight lines are having their its own equation. So let us assume the equation of the straight line L be ax plus by plus c is equal to 0, and the equation of the line L dash be a dash x plus b dash y plus c dash equal to 0. So dear students, here a, b, c, a dash, b dash, c dash are real numbers. A and b cannot be 0 at the same time. A dash and b dash cannot be 0 at the same time. Now these are the two straight lines. Now if we look into it, so there are two bisectors of these straight lines. So we see this is one bisector and another bisector is this one. Okay, so one is acute angle bisector, one is obtuse angle bisector. So in today's session, first we will look into that how to find the equation of these two bisectors. So two straight lines equation are given, L and L dash. As you see, the equation of L is given as ax plus by plus c equal to 0, and equation of L dash is given as a dash x plus b dash y plus c dash equal to 0. And what is our task? Our task is to find the equations of the bisectors. Now, the equations of the bisectors are something like this, that we define is that, equation of the bisector of these two straight lines, joint equation of the bisectors, I can say, joint equations of the bisectors. Joint means both, acute angle bisector and obtuse angle bisector are represented in the same statement. How it is? It is ax plus by plus c divided by square root of a square plus b square. This is equal to plus minus a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square. You see, dear students, there I use plus minus. That means if you use plus, you will get one bisector, and if you use minus, you will get another bisector. Now our point of discussion is that how to identify that which one among these two is acute angle bisector and which one is obtuse angle bisector. And to perform that, so let us give the name of these equations of these bisectors. Suppose we give that b as ax plus by plus c divided by square root of a square plus b square. This is equal to a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square. This is one bisector, and another bisector we name it as b dash, and that represents the equation ax plus by plus c divided by square root of a square plus b square is equal to minus of a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square. So these are the two bisectors. We want to know which one is acute angle bisector and which one is obtuse angle bisector. And dear students, to know this thing, there are two methods. You can use any of these methods. So I am going to discuss one by one method. Okay, the first method says something like this. Okay, so let me write out the first method. Method 1. In this method, what we first going to do, we want to take one straight line. Suppose we take the straight line L and we take another, any one of these bisectors, suppose B. So this method is based on the angles, the method 1. So the method here is that we take any straight line between these two straight line L and L dash. Let's take the straight line L, and between these two bisectors B and B dash, let's take B. There is no restriction that we need to take L and B only. You can take any straight lines, any one straight lines between L and L dash, and any one bisector between B and B dash. Now we took L and B. You can take L, B, L, B dash, L dash B, or L dash B dash, whatever. Now after taking these two, then we can find an angle between them. So if we look into this, a diagram, and if we draw that, the bisector as a red straight line, so this is one bisector. Okay, and another bisector is, this is another bisector. We do not know which one is acute angle bisector and which one is obtuse angle bisector. That we are going to find it out now. This is B and this is B dash. Suppose we take L and B. Now we will find the angle between them. Let the angle between L and B be phi. Then what we can find? We can find the value of tan phi. Okay. How we can find the value of tan phi? It is pretty simple to find the value of tan phi, because we know the slope of the straight line L and slope of the straight line B. As we know, so suppose M1 and M2 are the two slopes of two straight lines, then what is the angle between them? If you recall, if phi is the angle between them, that is equal to, phi is equal to M1 minus M2 divided by 1 plus M1 into M2, right? So this is the angle between them. If we find, suppose in this case phi, the angle between the straight line L and B, if we find that mod of this tan phi is less than 1, that implies what? That implies phi is in between minus pi by 4 and pi by 4, correct or not? Now, if this is the case, then we can conclude that the straight line B is an acute angle bisector between L and L dash. Why? Because if it is an acute angle, suppose this point of intersection is O. If LOL dash is acute angle, then its angle could be maximum of 90 degree, pi by 2. Then the bisector, that is LOB or BOL dash, in this case we are assuming you are taking LOB. If we take LOB, that has to be less than pi by 4. So the absolute value of tan phi has to be less than 1. Then what we can conclude, dear students? If so, here we can say like this thing, that if we get, if mod of tan phi is less than 1, that implies if minus pi by 4 less than phi less than pi by 4, this implies B is the acute angle bisector. Acute angle bisector. And obviously, if B is the acute angle bisector, then B dash will be what? B dash is the obtuse angle bisector. Correct? So in that way, we can find that which one is the acute angle bisector and obtuse angle bisector. Now, if mod of tan phi is not less than 1, that means if mod of tan phi is not less than 1, that implies what? Then we can conclude that B is the angle between L and B, then it is more than pi by 4. That means the angle that straight line B is not an acute angle bisector, it is the obtuse angle bisector. It is the obtuse angle bisector. And as B is obtuse angle bisector, the other one, that is B dash, is the acute angle bisector. Correct? So we found that method 1. So in this is the angle, by using the concept of angle, we are finding that which one is the acute angle bisector and which one is the obtuse angle bisector. Now the next point what we are going to discuss, dear students, is the method 2, that is related to the sign of the coefficients of the sign of the coefficients expression. So before I proceed for method 2, so let me tell you that the method 1, let me write it down, that in details about the method 1 from the study material. Okay, and you can just have a quick look into it, and after that we'll proceed to the method 2. So this is about the method 1, and here are the step-by-step methods. Step-by-step process we need to follow to find the which one is the acute angle bisector and which one is the obtuse angle bisector. Okay, now let's proceed for the method 2. In method 2, what we'll do, dear students, is something like this. Is that, let me write down first. Now, what are the equation of these two straight lines given? Let me write it here. So, equation of the straight line L was that ax plus by plus c is equal to 0, and L dash is a dash x plus b dash y plus c dash equal to 0. Now, we need to adjust these two equations if the constant term is not positive. That means our target is to make both c and c dash positive, and for that whatever the adjustment we need to make by multiplying a negative sign we will do. Let me give an example so that it is very clearly understandable. So if the two straight lines are given something like this, that first straight line we get something like this, that 4x plus 3y minus 6 equal to 0, and the other straight line is 5x plus 12y minus 5x plus 12y plus 9 equal to 0. Let's assume that these are the two straight lines given, L and L dash. Now we see that in the first straight line, the sign of the constant term 6 is actually negative. So what we should do? Our target is to make that 6 positive, and that is the only way we can do is that we should multiply both sides of the equation of the first equation as minus 1. So then what we will get? We will get minus 4x minus 3y plus 6 equal to 0. So this equation, if we write it down here, so it will be turning out to be, minus 4x minus 3y plus 6 equal to 0, and second equation remains the same. So now we will deal with these two equations. So make sure the constant term, that is both c and c dash, in context to the discussion of the generic equations, are positive. Once this is positive, then we are going to perform the following tasks. What is that? We are going to find the value of a dash plus b dash. After this adjustment, by the way, that we are going to find the value of a dash plus b dash. So we will find the value of a dash plus b dash. Now, if we find that if a dash plus b dash is less than 0, correct? Then the acute angle bisector will be the uh, if a dash plus b dash is less than 0, then the acute angle bisector will be the b. So let me write down the the bisectors equation as well here. Okay. So what is the equation of the bisectors? If you after this adjustment means after having the sign of both c and c plus positive, okay, we find the equation of the bisector b is equal to what? Ax plus by plus c divided by square root of a square plus b square, that is equal to a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square, and b dash will be equal to ax plus by plus c divided by square root of a dash square, sorry, a square plus b square is equal to minus of a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square. Correct? So these are the two equations of the bisectors. Let me repeat once more, dear students. If we find the constant term is negative, we will make the adjustment by multiplying minus 1, so that we get both c and c dash positive. After this adjustment, whatever the equation of the straight lines we are getting, we are assuming L and L dash, and then we find the equation of the bisectors b and b dash. Okay. After that, if we see that a into a dash plus b into b dash is less than 0, then what we can conclude? We can conclude that is that b is the acute angle bisector and b dash is the obtuse angle bisector. Then we can assume that b is the acute angle bisector and b dash is the obtuse angle bisector. Now, if the other way, that means if a dash plus b dash is greater than 0, if we get if a dash plus b dash is greater than 0, then what we can conclude? We can conclude that b is the obtuse angle bisector. That implies b is the obtuse angle bisector and b dash is the acute angle bisector. Correct? So we will see all these things by means of an example so that things will be absolutely clear. Okay. So this is the method 2, which is based on the value of an expression. Now the next point. So let me show you the relevant portion from the study material, so that you can have a very clear idea also. And after that, we'll proceed to the next topic. So to identify the exact equation of the acute and obtuse angle bisector, and this is a sign-based method. That's what I say, it is a sign-based method, because here we are finding the sign of that expression a dash plus b dash, whether it is positive or not negative. Okay, and at the same time we are also finding the whether the sign of the constant term c and c dash are same or not, and that is why this adjustment has been made. Okay, adjust the equation L and L dash such that both c and c dash are positive, and you can go through this statement. The next topic what we are going to discuss, dear students, is that how we can identify the bisector between two given straight lines contains a given point. Let me explain you by means of an pictorial description and diagram, and then we are going to discuss on this. So the topic what we are going to discuss is that the identifying the bisector between two given straight lines contain a given point. And let me go to the next page and describe in details. Suppose that two straight lines has been given. So let's draw these two straight lines something like this. One is the green one, as you see. Let me draw it properly. And the other one is the blue one, that is L2. Suppose. So this not L2, L dash, and the green one we can say is that this is a L. Okay. Now, and the equation of L and L dash are given to us. And apart from that, we have a point is also given to us. Suppose a point is somewhere given to us as P. Okay, with coordinate, let me write it here. Suppose a point P is given here with coordinate alpha comma beta. So what is our task? Our task is to identify the bisector between these two straight lines that contain a given point alpha comma beta. How to find that one? So we have been given the equation of L such that ax plus by plus c is equal to 0, and the equation of L dash is a dash x plus b dash y plus c dash equal to 0. These are the two equations given, correct? Now what we are going to do, dear students, is that we will find the value of two expressions. Okay, so the first and the point is also given. Let me tell you that point coordinate of the point P is given as alpha comma beta. What is our task? Our task is to identify the bisector, acute or obtuse. Means identifying the acute angle bisector or obtuse angle bisector between these two given straight lines L and L dash. Okay, contains a given point P. How to do this thing? For that, first step 1, we are going to find the value of two expressions, and that we defined as E1. What is that E1? E1 is A alpha plus B beta plus C. And what is E2? E2 is equal to A dash alpha plus B dash beta plus C. So these are the two expressions we find it out. If we see that both E1 and E2 having the same sign, that means what? Then we proceed for the step 2. If we find both E1 and E2 are the same sign, that means what? If E1 is positive, then E2 is positive, correct? Or if E1 is negative, then E2 is negative. If they are in the same sign, then what we can conclude? Then we conclude that the bisector of the angle containing the point alpha comma beta is ax plus by plus c divided by square root of a square plus b square equal to a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square. If we find both e1 and e2 have the same sign. Now if this is not the case, if u1 is positive, if u1 is positive, e2 is negative, or if u1 is negative, e2 is positive, that means they are of the different sign, then what we can say? We can say that the bisector of the angle containing the point alpha comma beta is this one, that is ax plus by plus c divided by square root of a square plus b square is equal to minus of a dash x plus b dash y plus c dash divided by square root of a dash square plus b dash square. Now let us take a representative example, to understand all these points we have learned so far in this today's session. So let us take one example, and with this example we are going to have our understanding extremely clearly, so there will be no doubt, I hope. Okay, so here is the question and what we are going to answer together. The question is that, dear students, you please open your notebook, and so you also do along with me. I will do a little slowly to explain each and every point. The question here is that for the straight lines 4x plus 3y minus 6 equal to 0 and 5x plus 12y plus 9 equal to 0, find the following. First question is that equation of the bisector of the acute angle between these two straight lines, equation of the bisector of the obtuse angle between these two straight lines. Question point C of this question is that bisector of the angle which contains the point 1, 2, and D, bisector of the angle which contains the origin. Okay, let's do it one by one. So what is that according to our learning, what we did so far in today's session? We see that L is what? We'll use both the methods. Okay, so first we'll use that angle method. That is, let me write it down here also, and I'm going to show you that using both the methods we are going to get the same result. Okay, and the only purpose of doing this thing is that you should have your understanding absolutely clear. So in this method, what are the equations given of the straight lines? L is 4x plus 3y minus 6 and minus 6 equal to 0, and L dash is given as 5x plus 12y plus 9 equal to 0. Now we know what are the joint equation of the bisectors. Joint equation of the bisectors is something like this: 4x plus 3y minus 6 divided by square root of 4 square plus 3 square is equal to plus minus, okay, 5x plus 12y plus 9 divided by square root of 5 square plus 12 square. These are the joint equation of the bisectors. That means what? We will take plus and minus. So, so if we take the plus one, so that means if we take the plus one, what we are going to get? We are going to get 4x plus 3y minus 6 divided by square root of 4 square plus 3 square is equal to 5x plus 12y plus 9 divided by square root of 5 square plus 12 square. So, and if you simplify, dear students, if you simplify this, plus 1, and you will get something like that 9x minus 7y. I'm not spending time in simplification. So you'll get 9x minus 7y minus 41 is equal to 0. So this is one bisector, but we do not know whether it is acute angle or obtuse angle. And the other one, what we are going to find, if we take the negative sign, that means what? Here you will take 4x. So here we're going to take 4x plus 3y minus 6 divided by 4 square plus 3 square is equal to minus of 5x plus 12y plus 9 plus 9 divided by, let me write the 9 properly, 12y plus 9 divided by square root of 5 square plus 12 square. So now if we simplify, dear students, the same manner, I'm not spending time in simplification. So what we'll get? We'll get 7x plus 9y minus 3 is equal to 0. So these are the two bisectors. One is B, one is B dash, based on our understanding. Now we need to find, suppose we give this name as B, and this name we give as B dash. Now our task is that to find which one is the acute angle bisector. And in this method, what we are going to find, we are going to take any of the straight line. Suppose we take the straight line L, and we take the straight line L, whose equation is 4x plus 3y minus 6 equal to 0. And let's take the other one is B, that is equal to 9x minus 7y, 9x minus 7y minus 41 is equal to 0. Now what is our task? Our task is to find the angle between them. Okay, if we assume phi is the angle between L and B, then what is the value of mod of tan phi we are going to get? The value of mod of tan phi we are going to get is that slope of the first straight line, that is L, is equal to minus 4 by 3. So that is minus 4 by 3 minus is slope of this another line, that is another bisector, that is B, is 9 by 7. So minus 9 by 7 divided by 1 m1 minus m2 by 1 plus m1 into m2, that is minus 4 by 3 into 9 by 7. Okay, and that is equal to what, dear students? That we are going to get it. I'm not spending time in simplification. We'll get 11 by 3, which is greater than 1. That means what? That means B is the obtuse angle bisector. Eventually, B dash, that is 7x plus 9y minus 3, that should be the acute angle bisector. So from here, what we can say is that the answer to the first question is that acute angle bisector is equation, we can write that. Equation of acute angle bisector is 7x plus 9y minus 3 equal to 0. And eventually, equation of obtuse angle bisector is 9x minus 7y minus 41 is equal to 0. Okay, so this is the way we can find the obtuse angle bisector. Okay, so that we are able to answer the the equation of the acute angle bisector and the equation of the obtuse angle bisector. Now the same thing I would like to show by means of the method 2, that means by the sine method. In that sine method, what is the equation of the straight line? Let us write once more. Okay, so here we are going to do the method 2. Uh, I'm just saying that, okay, exactly how I wrote method 1, method 2. In this method 2, so first we will write the equation of the straight lines. Okay, so equation of the straight line L is what? L is given as 4x plus 3y minus 6 equal to 0. 4x plus 3y minus 6 equal to 0. Now as we see that it is minus 6, so we should multiply by minus 1 so that we get it is plus 6. So that implies what? Minus 4x minus 3y plus 6 equal to 0. This is one equation. And the other equation what is given is that 5x plus 12y plus 9 equal to 0. And here we need to make any changes. So this is the equation L, means we can say this is actual L and this is what is L dash. Okay. Now what we are going to find is that the joint equation of that the bisectors will be what? Joint equation will be minus 4x minus 3y plus 6 divided by square root of minus 4 whole square plus minus 3 whole square is equal to plus minus 5x plus 12y plus 9. Sorry, let me write it here. So it is 5x plus 12y plus 9 divided by square root of 5 square plus 12 square. This is the joint equation, right, of the equation of the bisectors. Now what we are going to do, dear students, is that the same method like that we will take the plus and minus, and if we take the plus 1, so if we take the plus 1, then what we are going to get? We are going to get is that minus 4x minus 3y plus 6 divided by square root of minus 4 whole square plus minus 3 whole square, that will be actually 5. Okay, is equal to 5x plus 12y plus 9 divided by square root of 5 square plus 12 square is actually 13. And if you simplify further, dear students, so the value what you will get is that I'm not spending time in simplification. You will get 7x plus 9y minus 3 is equal to 0. This is one bisector we get. Okay, so this is one bisector. Okay, and another bisector we'll get by considering the negative sign, that is minus 4x minus 3y plus 6 divided by 5 is equal to minus of 5x plus 12y plus 9 divided by 13. Now, if we simplify further, dear students, so I am not spending time in simplification. So here you will get 9x minus 7y minus 41 is equal to 0. So these are the two bisectors. We are able to find it out. One name we give as B, the other name we can give as B dash. Now what we are going to find is that which one between these two is acute angle or acute angle bisector or obtuse, and the obtuse angle bisector. So for that we need to find the value of the expression. So that value of the expression I'm going to write is that in the blue color, it is A dash plus B dash. And from where we will take A dash? We will take A dash from this one, and A dash A B will take it from this one L, and B dash from this one. Remember it very carefully. Do not consider the equation that 4x plus 3y minus 6. It has been transformed to minus 4x minus 3y plus 6 equal to 0. So what we can say from here it is A is equal to minus 4, B is equal to minus 3, and C is equal to 6. And in this case, what we can say, A dash is equal to 5, B dash is equal to 12, and C dash is equal to 9. Now, if we find the value of A dash plus B dash, so what we are going to get? Minus 4 into minus 5. So let's find it out. So that is equal to minus 4 into 5, A into A dash, plus B is minus 3 into B dash, that is 12. Definitely this value is less than 0. Now as it is less than 0, what we can say? We can say the acute angle bisector is 9x minus 7y minus 41 equal to 0. Correct? So what we can say is that from here we can say that acute angle bisector sorry. This is less than 0. I made a small mistake. A dash plus B dash, if we look into the theory, A dash plus B dash is less than 0. That means our acute angle bisector should be this one. By taking the positive sign, this we took the positive sign, this we took the negative sign. So as A dash plus B dash is less than 0, then our acute angle bisector should be by taking the positive sign. So this implies acute angle bisector. So let me write properly. This implies the equation of the acute angle bisector is 7x plus 9y minus 3 equal to 0, and the equation of the obtuse angle bisector is 9x minus 7y minus 41 equal to 0. And you see the result as we obtained this method 2 is also same as result we obtained in the method 1. Correct? This is the way we found the equation of the acute angle bisector and the obtuse angle bisector. Now let's come to the point C and point D, means part C and part D of that question. That we can do it here itself. We need to find the bisectors of the angle which contains the point 1, 2. Okay, so by the way, let me write it here. So this we took as a +1, this is -1. So as we find, so let me use a different color pen. So we are going to solve this particular question here now. Is that for that what you need to find is that we need to find the value of the expression, that is E1 is equal to that we can get it from here, 4 x plus cy minus 6. In that we need to apply x equal to 1 and y is equal to 2. So that is equal to 4 into 1 plus 3 into 2 minus 6. So that is equal to 4, which is greater than 0. Just a minute. This we get as greater than 0. And we find the value of E2. E2 is actually in that second equation of the straight line. In the expression, you only take the expression 5x plus 12y plus 9. There, instead of x, we'll write 1, and instead of y, we'll write 2. So that means 5 into 1. Sorry. That 5 into 1 plus 12 into 2 plus 9. That is obviously greater than 0. So what we see? We see that both E1 and E2 are of the same sign. Hence, which one will be the equation of the equation of the straight line containing the bisector of the angle which contains the point 1 2 by taking the plus sign here, right? Whatever we get in the plus sign, that implies we get that equation of the bisector, that implies the bisector of the angle which contains the point, bisectors of the angle which contains the point 1, 2 is 9x minus 7y minus 41. Is equal to 0. Now let's look into the so it is clear. So now let's look into the part D. Here instead of 1, 2, it is 0, 0. So let me use a different color. So here what we can do is that I can do it in this space. Okay, so that as the color is different, we can make a difference. So we find the value of E1 here will be 4 into 0. Okay, plus 3 into 0 minus 6. That is obviously less than 0. And E2 is equal to 5 into 0 plus 12 into 0 plus 9. That is greater than 0. So as we see that E1 and E2 are of different sign, then what we can say? We can say that the equation of the bisector that contains the origin is by taking the negative sign. That means this one. So from here what we can say is that bisector of the angle which contains origin is 7x plus 9y minus 3 is equal to 0. So this is about the whatever we discussed so far today, dear students. And I explained both the theory part and with a representative example. Now, the next point what we are going to discuss is about the concurrency of three straight lines. Okay, we are going to find the condition. Okay, of condition of concurrency of three straight lines. So let's understand what is meant by the concurrency of three straight lines. Let's understand this first. So suppose we have three straight lines. Okay, one straight line in the blue color. What I draw, let me draw it properly. This is the one straight line. Another straight line what I am drawing in the green color, this one, and the other straight line I am drawing in the purple color. Okay, now if we see, all these three straight lines are passing through a single point, and that is known as they are concurrent. When three straight lines passing through the same point, then we can say that these three straight lines are concurrent. Now we are going to find what condition has to be satisfied so that we can say that these three straight lines are concurrent. Now when I say that these three straight lines, that means we know their equations. So suppose the equation of the first straight lines be a1x plus b1y plus c1 equal to 0. Equation of the straight line L2b a2x plus b2y plus c2 equal to 0. And equation of the straight line L3b a3x plus b3y plus c3 equal to 0. Now the required condition for the concurrency of these three straight lines is that the value of the determinant, that a1 b1 c1, a1 b1 c1, a2 b2 c2, a3 b3 c3 has to be equal to 0. And this condition is both necessary and sufficient. That means what, dear students? That means if we find that for some values of a1, b1, c1, a2, b2, c2, a3, b3, c3, that the determinant of this, a1, b1, c1, a2, b2, c2, a3, b3, c3 is equal to 0, we can conclude that the three straight lines L1, L2, L3 represented by the equation a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 is equal to 0 are concurrent. Means both, both the side it is true. That means if the straight lines are concurrent, then the value of the determinant is 0, or if the value of the determinant is 0, then you can say that these three straight lines are concurrent. Now let me show you the relevant theory portion, dear students, that from the study material, so that you can make a proper correspondence when you look into the study material and the video lectures of this class. And here it is, the relevant study material. So the three straight lines with general equations, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 equal to 0 are concurrent. Means these three straight lines intersect at a point or passing through a point, the way you want to define. If IFF, that's why I was telling it is a necessary and sufficient condition, if the following condition holds true, that is the value of the determinant is 0. So if IFF says that if the straight lines are concurrent, then the value of the determinant is 0, and also if the value of the determinant is 0, then you can conclude these three straight lines are concurrent. Okay, so with this I would like to conclude the class for today, and we will resume our class in the next session. Thank you very much.